Welcome to the Engerati studio. We are located at the Asian Utility Week, and with us today we have got Peter Nemcek. Thank you very much for joining us.
Thank you.
He's the Vice President of Research and Development at CyberGRID. Do you want to give us a bit of a background on CyberGRID before we get started?
Sure, no problem. CyberGRID is a Toshiba Group company, and we are focused on demand response, virtual power plants, microgrids. What we do is actually we develop software that helps utilities to manage demand response, to connect the CNI resources, to connect distributed energy resources, storage as well, and to monetize these flexibilities and offer these flexibilities on the market, or use these flexibilities for their own balancing purposes.
You are speaking on eBadge. Do you want to just expand on that for us and tell us all about it?
Sure. eBadge is a very nice and interesting smart grids project. It's funded by European Commission within FP7.
Yeah.
And I'm a technical coordinator. Telecommunication company Telekom Slovenia is the main coordinator, which is quite interesting. Since this project has to deal with the balancing of the energy, has to deal with the demand response, virtual power plants. So many ask, what the hell is Telecom doing in energy business, right?
Quite a bit, I believe.
Yeah. And otherwise, we are a group of 13 companies forming this interesting consortia. Coming from 5 different European countries. And yeah, this is now the last year of the project, so we have some interesting results already. And
you were saying that there's 3 messages that eBadge wants to get through.
Yeah.
And what are those?
Well, the first one is that telecommunication companies can liberalize the energy data.
Yeah.
The second one, I would say, is that virtual power plants can help in optimizing the whole energy value chain.
Yeah.
And the third one would be that, you know, when connecting markets, in Europe for some time now, it's all about connecting markets, integrating different markets. Also, electricity market is no exception. And one of the last pillars in this market are balancing markets. Till now, those markets were framed in the national borders, but these days there is an initiative to merge these markets as well. So within the project, actually, we have found if we merge these balancing markets, if we exchange balancing energy cross-border, then we can achieve a huge savings on the, let's say, on the global scale, on the Europe-wide scale.
Yeah. Expand a little bit for me on how data can be liberalized more within this particular region.
Yeah. Well, it's not just within this region, actually, it's within the whole Europe or globally, if you wish. As we know, electricity data is usually collected by electricity companies, distribution system operators, and they don't like to share it, right? So they like to keep it for themselves. And this then makes much difficult for new startups, for new market players to offer some advanced services, either energy efficiency services or even demand response services. So what happens then is that these new market players then develop their own communication infrastructure, which is costly, of course, and then because of that, many of these programs never start or are not successful. So this is where actually telecommunication companies come into the play. They have a very good telecommunication network, either mobile or fixed. They usually already have some equipment in homes or in companies, and it's just a small step to get also the electricity data into this infrastructure. In eBatch, for example, the telecommunication company has developed also a home energy hub, which is a box that connects different appliances, collects electricity consumption data, and also remotely control these appliances. So actually it enables monitoring, energy efficiency applications to be developed. Then it supports demand response. It supports remote control of distributed generation. So it's a whole bunch of services that could be applied to this, let's say, box or actually a system. At the end, all this data is transferred to the cloud of the telecommunication company, and in this cloud it's available to other market players. It's not closed, you know, it's not protected from the outside world like we see with the utilities, electricity utilities.
Yeah, it's all about really learning from each other and learning from each other's almost mistakes, I suppose, and successes, and building on those, isn't it? The cross-border exchange of balancing power, you were discussing how it decreases overall balancing costs. I think you were discussing this, going to be discussing this in the presentation. Do you want to touch on that a little bit for us?
Yeah, you know, the balancing energy and balancing reserves are the most valuable service that either TSO or utility is buying on the market. And if the market is small or it has certain limitations coming from geographical position or then to merge with the neighboring countries, these markets make sense, right? Because you create much bigger market, there is more competition, there is a better mixture of resources. Maybe some countries have more hydro, others have more gas or coal or whatever. So, and definitely when you put into this mixture also demand response and renewable generation, then you get a much better chance to find, let's say, cheaper resources, more efficient resources. To balance the electricity grid.
Definitely strengthen reliability of supply for everybody involved.
Exactly.
With regards to BPPs and their suitability for TSO ancillary services, how is that applicable to this region, and where do you see the opportunities in this particular region?
Well, as you know, electricity can't be stored, still can't be stored in huge quantities, economically efficiently. So the consumption and generation needs to be balanced all the time. And this is the task of the TSO or the vertically integrated utility to make sure that this is the case, right? So conventionally or traditionally, this was done by some quick gas power plants that could immediately jump in and supply these reserves in few minutes or 15 minutes or 1 hour. Depends on the ancillary services that we are talking about. With demand response, especially CNI demand response, you can get for quite competitive price a reasonable amount of reserves and energy that can be activated in 5 or 10 or 15 minutes automatically. and could help TSOs and utilities to more efficiently balance the grid.
Yeah.
So actually demand response on virtual power plant is just another puzzle piece in this energy value chain that helps everything work more smoothly and more efficiently.
Absolutely, yeah. What message do you want to get across during the course of this event?
Well, I think that let's say smart grids and especially demand response, distributed generation, storage, this is something that we can't avoid anymore, you know. Especially if we want to decarbonize our future. And by doing that, I think we are helping also local communities, local economies to have something out of this. For example, with demand response, why should we engage some conventional peaking power plants, burn some foreign gas?
Yeah.
Instead, we can send a signal to a local CNI customers to shed their power, to curtail their consumption or generation, and have something out of it. You know? The money actually stays within the community. All these CNI customers are rewarded for their flexibility, and this is how actually utilities could also support their local businesses.
Yeah, and just build up their own economies and strengthen their own supplies without spending too much. Yeah. Well, sound advice from you. Thank you so much for joining us. Unfortunately,
thank you for inviting me.
Thank you. I trust the rest of the conference will be very successful for you and you'll enjoy the rest of it. And to our viewers, thank you so much for joining us. There will be other videos for you to have a look at. Thank you again for joining us.